Yes, I believe it is streaming. See that? I don't know why that was off. All right. Okay. So I'm not sure if anyone is viewing this.
Currently not.
Oh, we have two. Barbara, are you on the new feed?
I'm seeing
Can't you
streamed
put in a
10
little
minutes
message
ago,
telling everybody to go
and
to the
it's
We did.
trying to
Yeah.
load.
So I put a comment underneath with the new stream.
So that's the only problem we have is
Oh, okay, I see.
this view
Let me
is
try
90
that.
degrees.
Oh yeah, it's got me with my hat on. That was a while ago. Yeah, April 20th.
Unfortunate that you can't.
Oh, I can see your face now.
But then your
Oh!
aspect
On the
is
new.
anymore. It's the
Yeah, it's on the
stupid
new
phone.
URL. I think they can probably hear what we're talking about.
Fantastic. What I am going to do is grab this and then just get in, if I can, and edit the planetarium. I'm not sure if I have time. Planetarium website with the latest link, because I think it's just you and me watching at the moment.
I see a few comments in the chat, like still no joy, still spinning wheel, and it did freeze again, so I don't know.
This new YouTube
Yeah.
link.
Yeah, like it showed your face moving for a while, and then it just
It
froze.
starts buffering and buffering.
Yeah, spinning wheel.
I was noticing that yesterday on YouTube. And I was looking at some stuff and going like, why are you buffering? This is not some archaic thing that I'm looking at. So I should go Facebook Live. Everybody go.
All right. Facebook Live. All right. So I am in the. Oh goodness. Okay, so I'm going to take the link off, and then put the new link on for. So I've just updated the planetarium website with the new link, but that is not going to help with the link for Facebook, because a lot of people have gone to the Facebook Live link. Yep. Well, I can comment for Mount Wilson.
What it is we just
Oh goodness, this is not the way I was hoping that our evening would progress.
that's the reflector.
Okay. Alrighty. Well, I'm not sure how many people are actually here. We have,
So yeah.
fingers crossed.
That the one you saw? That is that other camera.
In space, no one can watch your stream. So with the new link, it says just the whirligig of waiting,
One's a true German.
which is a shame.
And this is an actual like a wedge.
It says it's an excellent connection, but the
Yeah.
YouTube seems to be having issues. So I'm not sure what to do here.
I could
Gentlemen?
try it on Facebook, see if it comes up when you put the URL, then you
We'll just keep tracking the moon until we establish something. So
Barbara's suggesting we do a Facebook Live.
go for it.
try to see
Can we?
I have no idea how to do that.
There's a whole thing you click for live videos, but I don't know how you.
Live stream. I
Not live stream, just who does the.
do.
You do. So why don't you log in then?
Yeah.
Okay. So if you log out, you log in.
So I can. This is.
All right.
Wait a minute. YouTube. I'm thinking of Facebook.
Yeah, Facebook.
Yeah, Facebook.
Okay.
YouTube is not working. We're gonna try.
YouTube seems not
Right.
to be working because it's getting the whirligig of death.
Yes.
Oh, I think it's intermittently
buffering. It's having
I
buffering.
can hear and see. Can you guys?
Yeah, look at it.
Oh, okay. Well, see, it's buffering even though we have an excellent connection. I switched over to Twitch.
Are we on Twitch?
If you look close enough into the void, you can imagine seeing Voyager 1 of the life forms. Okay. All right. So are you logging into Facebook on here?
I think let me think about this for a second. I don't think we can stream to both YouTube and Facebook at the same time. So we'd have to jettison, or at least we'd have to stop, not necessarily end the stream, but we would have to stop going to there, and we'd have to start streaming to Facebook instead. So actually, we could probably log into Facebook Live anywhere, but I've never done it before.
I have no idea. Do you want me to get out of the hot seat then?
Yeah, just get out.
Okay.
Unfortunately,
guys-
that's your only camera.
You mean webcam?
Yeah, I don't have webcam.
I can't see your board. Okay, so I'm gonna get another.
Just go down to Google Chrome.
Well, we're going to definitely have to come back and finish it
Okay,
off.
so I need to open up another.
Oh, now we've got an error.
Where? Oh,
Not,
there.
don't worry, not you.
Okay.
Errors.
Playback error.
Playback error. Yeah.
Which is on YouTube and not our end.
Let's see. How do I get?
You can test.
I never get there.
YouTube.
Mount Wilson Observatory or YouTube. So let me go to YouTube right here. Let me go to search.
I don't have
Observatory.
speakers. See, they shouldn't be doing that.
Commercial Star Party. Okay.
They're buffering a lot.
Yeah.
Okay, so Glendale virtual field trip,
I want
and it's really weird how something.
YouTube. I want.
Look at that. That's just from last month. Okay, there it goes.
No, that's...
Then we're
Oh yeah, there we are. All
Buffering.
cold.
So this is us here.
yes, but it's a month ago, and look how it's buffering. I just changed.
Yeah, so I clicked that, and this is what I'm getting, which is tonight, but it's...
Looks like it's going in and out. Other people were seeing you earlier. Now I can see you, so. Not
Yeah, I'm just... Yeah, from our YouTube stream, it says an error occurred.
Yeah, mine just.
Oh,
But you know, the interesting part is, you guys are still streaming.
Well, yeah, but it says, hey, you're on, we can see you and hear you. So
Yeah.
shall we just...
okay. Let's just continue.
Let's
Continue.
just continue.
Okay.
See how it goes.
All right.
We'll
This is your
we'll ignore all the
live.
warnings. Okay.
Oh, I see what's going. See, there it is.
There we go. There's Tom.
So Tom is about to leave. I predict.
Okay,
Since
so
I'm behind you now.
I'm just going to assume that things are back to normal, and I am going to keep having a look over to my left-hand side. And if I look that way, I'm looking at a different laptop which has the YouTube feed. Now, it says that an error occurred, and please try again later. Yet in the chat, you are currently saying, bingo, we can see and hear you. So
It's weird we
I'm
don't get
just going
feedback.
to go ahead. Thank you, Marilyn. I am just going to go ahead and start the evening 20 minutes after I started it the first time. So we have no problem. Houston, we have no problem. It's a go. All right. Welcome to the historic 60-inch telescope dome here atop Mount Wilson in Southern California. I know this does sound familiar. I think I've said it twice already this
Take
evening.
3.
My name is Dr. Jenny Krestow, and I am one of the astronomers up here this evening. I am joined by Dr. Christopher Byrne, who's an astrophysicist whose day job is at the Carnegie Observatories in Pasadena. Also this evening we have Mr. Richard Bell, who's a telescope coordinator up here. And then we have Mr. Tim Thompson, who is a board director here at Mount Wilson Institute. And there's Daryl Dooley, who's our telescope operator, and of
Walking
course,
for our promotion.
Tom
You know
Meneghini,
me.
who is executive director here at the Mount Wilson Institute. So there's a whole bunch of astronomers up here this evening. We have a great time when we get together. Yes, we are all educators. We're all being vaccinated, which is why you will see us without masks on. And we are also in the relative outside. I'm just going to tip my laptop and show you the fact that our dome is open to the sky. It is not entirely dark yet, but our first target tonight will be the moon. So in another 5 or 10 minutes, we will be able to head over to the moon. But I know that a lot of you have been joining us every other week for these live streams, and I did want to give you a little bit of, I don't know what you want to say, background information on kind of the way the program evolved and the players that are involved. So I'm going to go over to YouTube slides. That is not, oh goodness, where did the slides get to? That one? No.
Next one.
That one. Haha. So it should be showing Mount Wilson Virtual Star Party for May the 18th. That is today. And these are the people who are joining me this evening and bringing you this fabulous virtual star party. This whole, I guess, team of individuals and idea came about in large part because as part of my job at Glendale Community College, I teach in the planetarium. So I'm astronomy faculty, astronomy and physics faculty, but I also, part of my job is outreach to the local community. And we have a lot of school kids come through every year to the planetarium. Now the planetarium is this lovely tiled dome right here. I can zoom into that. And every year we probably have upwards of about 6,000 elementary school children who come for a visit. The right-hand side of this image is a shot of actually inside of our planetarium. That lovely image of the Milky Way is not what you'd see with that amount of light in the dome. Obviously, if any of you out there in YouTube land have ever been into a planetarium, really you need the lights all turned off completely to see that beautiful of an image. But working at GCC, I am actually quite close to Mount Wilson. Oops, hang on, there we go. So Glendale Community College is kind of at the north side of greater LA. And you can see a map here of how long it actually would take to drive from GCC up to Mount Wilson. According to Google Maps, if I stick to the speed limit, that would be 41 minutes. We are the closest community college to Mount Wilson if you're driving. Now, if you have the ability to fly, I guess the closer one would be Pasadena City College. But, you know, less than an hour to get to Mount Wilson is wonderful. So I'm at GCC. Obviously, we have a lot of Mount Wilson folk here, but we also have Chris Burns, who is an astrophysicist working out of the observatories of the Carnegie Institution for Science. And this is their kind of headquarters in Pasadena. So we are all interested, we're all, I guess you could fairly say we're, you know, science nerds. But astronomy is, for most of us, our science of choice. And if you're an astronomer, then Mount Wilson will figure largely in what you learned about and what could be learned about historically when you're studying astronomy. So the 60-inch telescope in the middle of the screen here is the dome in which we are right now. There is a larger telescope on site. We are not in that dome. These two telescopes were built largely because of one gentleman, and that is George Ellery Hale. He founded the Mount Wilson Observatory. He himself was an astronomer. His, I guess, area of astronomy that he was most interested in was solar astronomy. And the first telescopes up here on Mount Wilson were actually solar telescopes. And a map of the area will actually show you a couple of the solar telescopes. There's the 150-foot solar tower here, and then the 60-foot solar tower. And these are solar telescopes. So there's a lot of different types of astronomy that happens up here on Mount Wilson. And really, at the beginning, the first half of the 20th century, this was the place to be. Atop Mount Wilson in Southern California was the place to be. We had the largest telescopes that were built, and a lot of astronomers figuring out kind of where we exist in the universe and how big the universe really is. That work was done by Edwin Hubble, who was a staff astronomer here at Mount Wilson. So there's a lot of really interesting stuff that has been learned. We still have some research being done. The Chara array is cutting edge research, and we have research projects on some of the smaller telescopes as well. FYI, if you did hear about the Bobcat fire, which was in the area last September, this is a screenshot of flames that obviously very close to the observatory. This picture is taken from the 150-foot solar tower facing south toward the city of Los Angeles. This is the 60-foot solar tower. And I think you can see, if you look up the top, the date is the 17th of September of last year. So there was a huge wildfire that came through very close, and it's only really by the heroic efforts of the many teams of local firefighters that Mount Wilson was saved. What you're seeing here is, in fact, a backfire that was set to, I guess, burn the local scrub, I suppose. Vegetation, so that the real wildfire didn't have any fuel when it came close in. But those of us sitting at home watching this, there were a few hours where I actually was teaching an astronomy lab that night, and I had to end the lab. I was just speechless. I just kept refreshing the page, and I thought for sure Mount Wilson would melt, and all of the history that went with it. But it was, I think a couple of hours later, we were told that this was a backfire, but there was so much going on, and it was happening so quickly that I don't think word got out early on. But yes, Mount Wilson is still standing. It is still beautiful. For a perimeter of the Bobcat fire, LA is down here at the bottom, and Mount Wilson, I think, is somewhere around this neighborhood. This map is, I had a little indicator, but that seems to have disappeared. The map is, it was a very big fire. Now, Mount Wilson was built, and this 60-inch came online in 1908. Yeah, okay, I'm just getting the heads up from all the people who know the history better than I do. 1908, but one of the things I think is fascinating is that when they brought the telescope up the mountain, think about that, 1908, when was the Model T, the Ford Model T car built?
That's around
about the same time? Yeah, the early 1900s. They had some steam-powered locomotion type vehicles, but as you can see, most of the equipment was brought up with the help of mules. And this is the 60-inch telescope that was being brought up the mountain. And not Highway 2, which is presently the road that we take, but the what's now called the Mount Wilson Toll Road.
1908.
So it was, 1908, the Ford Model T
to 1927.
was produced, yes. Okay, so this was obviously, the telescope was brought up before 1908 because its first light was 1908.
Yeah.
So this was before the Model T came out. We call it the 60-inch telescope because the diameter of the primary mirror, shown here, is 60 inches across. And for those of you speaking metric, it's about 2.5 meters. So I've got a few other images of some things that are sort of underneath. And now I think it might
actually,
very well be.
We pointed out this last time. This is the float that sits in the mercury bath.
Oh yeah, we haven't talked about the mercury bath. We can come back to this.
We did last time. But not
Last time we talked about it, yes. But I think what we are going to do now is have a look at the moon, because it is substantially darker than it was. There, you can see the sky up there. Substantially darker than it was even 10 minutes ago. And I think a view of the moon would be really quite nice. So do we have the moon?
Yes.
Yes.
Here we go.
We're looking through the refractor first.
That is not what I was hoping we would see. So here's the moon. Now the moon is a waxing crescent moon this week. New moon was last Tuesday. So this week it is a 7-day-old moon, and this is a waxing crescent, and you can see that it is not completely still. The image that you're looking at is shifting around a little bit. That's not actually the moon waving at us. That is the effects of the Earth's atmosphere. So the atmosphere is hundreds of kilometers thick, and looking through the atmosphere is a bit like looking through water. If you've ever looked at the bottom of a swimming pool, and if there's no one swimming in the swimming pool and no one's been in for a while, the water can be quite still, and you can see things on the bottom of the pool. If there's a coin down there or a rock down there, you can see it quite clearly. But the minute, the water has some turbulence with people swimming around, you may be able to tell there's something down there, but it keeps, the image of what you're seeing isn't clear because of the turbulence of the fluid between that object and your eyes. The atmosphere is a fluid, and turbulence in the atmosphere can affect how clearly we can see the objects in outer space. This is the primary reason that astronomers love using space telescopes, because space telescopes are in space, necessarily. They are above the atmosphere, and they do not have this shifting, blurring effect to contend with. So we have a lovely image of the moon here. This image isn't quite what you would see if you went outside. If you went outside and looked up, the crescent moon would be over in the west.
It's flipped horizontally.
It is flipped horizontally. I'm trying to think of, it's flipped horizontally and then maybe
Rotated 90 degrees.
rotated 90 degrees or?
It's the difference between the two telescopes. We have two telescopes that are working.
Yes.
One's an equatorial mount, one's a German equatorial mount, and they kind of shift it. Some can actually look straight up, some cannot. And the refractor can't because it's piers in a way. Obviously, the 60 doesn't have anything underneath it to prevent that.
It's called a
Yeah.
meridian flip. Is what.
Okay, so we have the meridian flip, but this is not, if you go outside and look at the moon, it won't look like this. It will look like it's being flipped horizontally, the image, and that has to do with the optics of the telescope. But one of the things I like to point out is kind of the mare and the man in the moon. So Richard is pointing out with the cursor the head.
His arm goes up,
Okay, that's,
and one arm goes out that way, right?
Oh, is that how that works?
I was about to say, I see a different man. I personally see a third grader in the moon.
I see the Hummel on the moon, the German Hummels,
The German Hummels.
the
Okay,
little statues.
really?
Yes.
I see a third grader throwing a baseball my way.
Okay.
This is the fabulous thing about astronomy.
You see what you see.
You see what you see, and I guess I hang out with a lot of third graders. So I'll see.
I grew up. My girlfriend was German, and their families, and they had Hummels everywhere. So I see that big head that they had on the Hummels, and his little body, and his leg is coming down, and his hand is in his pocket because he's very depressed of trying to grow something here.
Okay, we're all looking at Richard like, mm-hmm.
Yeah, I've been drinking too much. No,
But if you want to put the cursor where the Apollo 11 mission landed,
is it this one?
nope.
Apollo 11?
It's
No, it's in
in
the Mare.
Mare Tranquillitatis. So go down, 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 left, 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 left. I think it's over there on that side. Yeah,
Is it this?
I think it's somewhere down. Oh wait, it is on the other side because it's flipped.
It's flipped.
Oh,
So
so
is it in
frustrating.
there?
Yes, it is down in that quarter. Well, in the Mare. You're in the Highlands. So the Mare, for those of you who may not be familiar, are the darker, smoother parts of the moon.
Okay, so it's opposite
And
of the
mare
sun.
is plural for marea, spelled exactly like Maria, but this is Latin for sea. So mare tranquillitatis is the sea of tranquility. So I believe marine comes from the same root word in Latin as mare.
Yeah, it's right in here.
And
It's right there.
Galileo,
It's right
when
here.
he first looked at the moon with the help of a small telescope,
there.
saw these mare and thought that they were huge, flat oceans. His telescope was not as good as the ones we're using tonight, and it did not have the resolution to see small craters in these large, darker areas. So Galileo lived in northern Italy, not far from the Mediterranean Sea, and he would go out and he would see the sea is dark, and it's certainly smoother than the land that he was living on. And he looked to the moon and saw these dark, smooth areas, and he thought that they were lunar seas filled with water. They're not. What we now know that they are ancient lava floodplains. So early on in its history, the moon was pummeled by large asteroids. Not large enough to break it apart, but large enough to create a very large crater. But early on in its history, the moon had not cooled and solidified the way it is now. It still had a hot, molten interior. So when a large asteroid slammed into the crust, it cracked the crust of the moon, and the magma could ooze up through the cracks at the bottom of the crater, fill the crater, and then solidify. And I don't know if you've ever looked at solidified lava here on the Earth. If you haven't, hop over to another YouTube channel, because watching lava flow is kind of mesmerizing. But the lava, when it cools here on Earth, is very, very dark. It is black. And this is it as dark as Earth lava? It's basaltic, but it's the same type of stuff. It certainly doesn't look as black as quenched Earth lava, but it's, it's certainly darker than the areas around it. So the areas around it are considered the highlands. Those are where the smaller, more numerous craters are. And these are going to be older surfaces. The mare tend to be younger being still billions of years old. Both the Earth and the Moon are estimated to be around 4.65 billion years old, with the Moon being slightly younger than the Earth. Now, Richard has just zoomed in, as I think you saw, and you can see some of the craters with a close-up view. But this also gives you a much clearer, view of the atmospheric seeing that we have, which is that shifting kind of blurring effects of the Earth's atmosphere. So it
That's
kind
your
of
Apollo
looks
light
like you're looking through water, but it's just the atmosphere you're looking through. All right, so have you got the cursor where the Apollo 11
It's in
landed?
this area right in here.
Right there. No, we cannot see the flag. No, we can't see the lander. No, we can't see the footprints. Can you give us an approximate scale? We're talking probably tens or hundreds of kilometers across here. Oh, he's gone to check. I'm not sure how far we're zoomed in, so I'm not sure.
We can switch over to the 60-inch too, and just because that I probably can.
Because 60's in a different area.
Okay. This is not the 60-inch.
No,
this is the
refractor.
I was wondering why we could see the whole moon.
This 60 can't see the whole moon.
I was about to say, how are we seeing the whole moon in 60? So, for everyone out there joining us in the live stream, this is a view of the moon, not using the 60-inch Mount Wilson telescope. It is using a much smaller 5-inch refracting telescope that Richard is showing you a little webcam image of here. This is also on top of Mount Wilson. If you look toward the top of the image, you can see the city of Monrovia, which is just south of Mount Wilson, south and a little bit to the east. But that's greater LA down there, and you can see all of the light pollution. This is the image from the 150-foot webcam the webcam atop the 150-foot solar telescope tower. And this is the glow of LA. And I mean, it's so bright that you can't, I mean, some of the areas you can see kind of roads and kind of neighborhoods, but then you get to kind of downtown LA, a little bit up to the right, and it's just one big blur of light. Yep. So the foreground mountains are the foothills just north of Pasadena in that last image. But this is the view of the Apollo 11 landing area as viewed through a fabulous 5-inch refracting telescope. Now, I don't know if you want to give a little more detail about your refractor, Richard?
It's a 130 millimeter refractor. And like you said, it's up here at Mount Wilson, so it's full remote control. Unlike the 1908 60-inch, which doesn't remote control anything. So it does have drive motors, though, and that's what we need.
Yes.
Are we going to move to the 60-inch?
Yeah, why don't we move to the 60 inch, and then we'll cruise our way over to the...
Now this is the 60.
All right. So you can see we are now slewing the telescope so that we can see different areas.
It's all
And you can see here craters on top of craters on top of craters. The moon has a very pockmarked surface. It was pummeled by objects impacting the surface for billions of years. It still is hit, as is the Earth, as are the other planets and the other moons in our solar system. But the rate of impact is much reduced now. Unlike the Earth, the moon does not have plate tectonics. It doesn't have weathering with wind and water. There is no liquid water on the moon to do any erosion. There is no atmosphere, so there's no wind erosion. So what you're seeing is pretty much what the impacting objects produced billions of years ago. There is some way to very subtly change the surface of the moon. There are micrometeoroids that can hit, so micrometeorite impacts. There is also the solar wind, so there's charged particles that can impact the moon. And this is a very, 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 very gentle sort of degradation of the surface, if you would. But most of what you're seeing is pretty much pristine from the 3 to 4 billion years ago era of heavy bombardment. So what are we looking at? Do you guys know which crater we're looking at?
We're heading to Apollo 11.
Oh, we are now heading to Apollo 11. So we have one of our telescope operators over at the controls, and he is slewing the telescope. So we have a view of the Apollo 11 landing site as viewed through the 60-inch. We are still not going to see the footprints. That thing kind of in the middle at the bottom on the left, that is not a footprint. That's 2 craters. I looked sideways and looked back, and I thought, oh, it's a footprint. Not a footprint.
it's a big foot.
The footprints are far too small for us to be able to see. I do believe the lunar rover tracks were
right there.
imaged by the
Is that it right
Lunar
there?
Reconnaissance Orbiter. Yeah, I think we found the region of the Apollo 11
Need to come down just a
landing
little bit.
site.
Oh, yeah, there it is.
Yeah, come down just a little. Telescope. We'll make the picture rise. There we are.
That's right.
All right, so Richard and Chris are figuring out exactly where the Apollo 11 landed.
Okay, Ed, bring it down. No, the other way? The other down?
The other down.
So it comes off this point right here, and comes north, and it's right there.
Yes, right there, exactly. So you're going to have to use your imagination and imagine an American flag there, and some footprints, and what else did they leave there?
Reflectors.
Reflectors, the retro reflectors. So the NASA astronauts, when they went up there, they did leave some equipment on the surface, and one of those is a reflector. So NASA actually sends laser pulses to that reflector on the moon, and those pulses return. And by measuring the time it takes for that light to get from the source up to the moon and back, they can, knowing how fast light travels throughout the atmosphere and the vacuum of space, they can figure out the exact distance to the moon down to the nearest centimeter, I think for sure.
It's pretty precise, yeah.
It's pretty precise because they know that the moon is moving away from the Earth at a rate of about 1.7 centimeters per year.
It's a little more than that. It's about 1.5 inches per year.
1.5 inches.
Yeah.
I don't speak
It's
inches.
three. It's about three.
Three,
centimeters or something.
okay, 3 centimeters. This is one of the things when you're a scientist,
Lickety-split.
you train yourself to speak metric, and I'm like, wait a second, it's just what? 1.5 inches per year. So yes, they know that the moon is gradually moving away from us, very, very gradually, and they can actually measure the increase in that distance on a yearly basis by these experiments where they bounce pulse lasers off the reflectors that the astronauts left when they walked on the moon. Personally, I think walking on the moon would be really, really, really cool. I don't envision doing that in my lifetime, but I can always
Kinda like
dream.
walking at the bottom of a pool.
I've never walked on the bottom of a pool, Richard.
Do a little scuba diving.
I have not been scuba diving. Swum to the bottom of a pool. All right, so this is the moon. Do we have any other interesting
I think we can move
sights on the moon? Or shall we move on from the moon?
Yeah, because we want to get into the ghost of Jupiter before it gets too low.
All right, our next target is going to be a planetary nebula that is known as the ghost of Jupiter. Has nothing to do with Jupiter.
You want to show the oceans?
Absolutely. Okay, let's have a look at the actual dome itself. I'm over here on the right-hand side of your screen. Mr. Richard Bell is beside me at the other computers. We have 1, 2, 3, 4, 5, 6. There's another 7 computers this evening. So I'm like looking at all sorts of different things. But this is the wonderful 60-inch telescope. You can see where the dome is open in the sky right above my hand up here. Actually, that way. But now you can see it move. I think we're back up.
Yes, we
Reconnection
are.
successful. Fantastic. Okay. I'm not sure
are we
what
looking at?
we're looking at.
There
That
you
was
are.
Zoom. I think we're back. Okay. I think we're back. Hopefully we're back. We lost all internet there for 30 seconds.
Oh, that was this.
No one's quite sure why. So one of the glitches, maybe it was the ghost of Jupiter, didn't really want to be seen tonight. It's having
Okay, good.
it's having a moment. What can I say about the ghost of Jupiter? The ghost of Jupiter is a planetary nebula that has the same apparent diameter and now everything's pitch black, the same apparent diameter as the planet Jupiter. So the planet Jupiter is about half an arc sec? No, half an arc minute.
No, yeah, half arc minutes.
Yeah, it's about a half arc minute. For those of you who don't know what an arc minute is, you may remember from school that there are 360 degrees in a circle. So horizon to horizon, you have 180 degrees. Each degree is further divided into 60 arc minutes. Each arc minute is divided into 60 arc seconds. So in each degree, you have 3,600 arc seconds. And yes, astronomers do need to be that specific, because when you zoom into a very small patch of the sky, 1 degree could be bigger than your entire field of view. And if you want to talk to other astronomers and say, hey, I saw this really cool thing, point your telescope at these coordinates, they need to be very precise in their coordinates. So we have arc, degrees of arc, and then minutes of arc and seconds of arc. And the planet Jupiter is about half an arc minute across in diameter when you look at it with a big telescope. So the ghost of Jupiter subtends about the same arc measurement. So about the same size. Not sure beyond that what the historical reason is for calling it the ghost of Jupiter. It is not the same coloration that the upper clouds of Jupiter are. So if you remember what Jupiter looks like, it is kind of stripy with creams and yellows and oranges and a bit of kind of rust brown in there. The ghost of Jupiter is none of those colors, and it does not have stripes. So they are zooming into it now and centering it for our view. But the ghost of Jupiter we are doing as our second target because it is fairly low on the horizon. So this 60-inch telescope is quite limited in which direction it can point to. You can't get too close to the horizon because it just doesn't go that far. I mean, the equipment isn't designed to go like flat down to the horizon the way that my own personal Dobsonian telescope, you can do flat, perfectly horizontal. This telescope is not made for that. Ooh, that's looking good. Should we go over and have a look at it?
At your,
All
as soon as
right.
you like.
Here we have it. So, whoa, they're changing the exposure time.
Well, that's
it
what
was
happens
there,
when
and now it's not.
That's what happens when you peak too early.
Yeah, I'm impatient.
there
I
in
wanted
just
to
a
show
second.
everyone how cool it is. So what is the exposure time we're working with now?
14 seconds,
Okay,
but we could do all kinds of stuff. There you are.
there we are.
Yeah. So we're trying to show you guys what this would look like if you had your eyeballs at the telescope. And so this is approximately what you'd see if you were up here with us and you could look through an eyepiece.
There we are. Made it
Hey,
brighter for them.
that's nice.
It's weird. You got to make it bright here to make it show up on YouTube.
Yes. Yeah. So we have, what we're looking at here is a planetary nebula. And planetary nebulae are not planets. They don't have anything really to do with planets. They are the result of the final stages of stellar evolution of a medium mass star. So stars come in, many different masses. They are observed to have different tinges of red and orange and yellow and kind of white and then a blue-white. They all form in the same manner. They form as a result of the collapse of a molecular nebula. This would be molecular hydrogen. And Most stars that form are not very massive. They are certainly less than the mass of our sun. And the low mass stars are, less than really 40% the mass of the sun. So the sun is considered a medium mass star, and as it uses up the nuclear fuel in its core, and that nuclear fuel is hydrogen, over time, the great temperature and pressure in the core of the sun allows the hydrogen to fuse into helium. But if you run out of hydrogen fuel, eventually that fusion process slows down and the star starts evolving. First it puffs up to a red giant, and then it can become a variable star and be on the instability strip, and then it can grow even larger to be a red supergiant. But eventually, when no more fusion processes are possible in the core is very hot at this point. It puffs off, and it has strong stellar winds, and it puffs off the outer layers, what had been previously kind of an outer envelope of hydrogen gas. Too cool to fuse, here you can see it puffing off. And this has what looks like two rings around a central dot. The central dot in the center is a white dwarf. So this is the former core of a medium mass star. It had been where hydrogen fusion had happened billions of years or hundreds of millions of years previously, but now the fuel fused up to carbon. There will probably be some oxygen in there as well, and that core has been exposed for our view as the outer layers get blown off. They get kind of puffed out in spherical rings and in spherical kind of bubbles, I would say. They look like rings, but in fact they are bubbles. So there's material kind of in front and behind, but we see the rings kind of on the side. So this is a planetary nebula. It is a little bit blue, a little bit green. I don't know if that is showing up well on the YouTube feed. Crickets are sounding in my life. And this is the ultimate fate of our sun. Our sun will eventually end up looking like this. Now, those spherical bubbles that are expanding away from the white dwarf, they are going to certainly be bigger than the radius of the Earth's orbit around the sun right now. So they're quite large. How big do you think they'd be?
Oh, they're many AUs. I'd say thousands of AUs.
Yeah. It's not just hundreds, it's probably thousands of AU. So an AU is an astronomical unit, and it is a unit of distance that astronomers invented because miles and kilometers just weren't good enough. When you're talking the distance from the Earth to the sun, that's approximately 149 million kilometers, 93 million miles. And then Neptune is 30 times that distance, so 30 times 149 million, blah, blah, blah. That's a lot of zeros. I can't do that math easily in my head, not in the middle of a live stream, so I'm just going to say 30 AU. And you know it's 30 times the Earth-Sun distance. The Earth-Sun distance being the standard and the unit of measurement for an astronomical unit. So this planetary nebula here, from one side of kind of the outer fainter ring to the other, and that bubble is going to be 1,000 AU, something along those lines. So this is many, many times bigger than the orbit even of Neptune. But this is the ultimate. Wow, what was that?
I don't know, we have a glitch.
Oh, a glitch. We just saw a lovely picture of a campsite. But we're back to the planetary nebula. So the white dwarf at the center is a very, very hot remnant. It's a stellar remnant. It is glowing kind of white blue hot. It's emitting a lot of UV radiation, so that's very energetic radiation. Don't go anywhere close to any of these because you'll get a really wicked sunburn. As that white dwarf, which is predominantly carbon with some oxygen, cools down, as it crystallizes, because it had been under great pressure, this is something that has the potential of becoming a diamond. So there are a few, I think there are 3 at this point, diamond stars, as they're known, out there in space, and these are cooled and crystallized white dwarfs. So they are 3,000 kilometers in diameter, this old compressed heart of a medium mass star that has cooled and compressed to be diamond material. But don't plan on going and mining one anytime soon. I think the closest is about 50 light years away from us. But this is our second target, the Ghost of Jupiter. The distance to these planetary nebulae is pretty difficult to determine because we don't necessarily know how big they are.
Yeah.
They could be large and far away from us, or smaller and closer and appear exactly the same. So it is quite difficult to determine. Aha! Although apparently some astronomers have estimated that it's about 1,400 light years away.
Yeah, so that's going to be a lot bigger than several thousand AU.
Oh yeah, that's going to be a lot
parsecs.
bigger than several. Yeah, yeah. So this is what we have. So do we have another target lined up?
Yeah, we're going to go to a earlier stage than this. We're going to go to that carbon star.
A carbon star. Okay. I like carbon stars. All right. So the carbon star is Y Canis venetici. Canis venetici, the hunting dogs. I don't speak Latin, so I'm not sure how to pronounce that constellation name. But
Kirsten used to know this. She made a...
Canis venetici? Venetici? Venetici. Is that Italian or is that... Oh, it is Italian. Okay. Well, there you go. We are going to Y Canis venetici. It is a single star that has used up all the hydrogen fuel in its core, and it has got to the point where there is a lot of the carbon that had been formed in the core has managed to migrate out, and for various reasons we call them carbon stars, and I won't say any more until we actually get to it.
We're just trying to
We're trying to see if we can freeze it rather than...
have it lose when we move the telescope.
Okay.
Now you think we're looking at the sun.
I was about to say, wow. It's a, yeah, wow. Oh, look, it's a UFO. No, just
So it
goes to
certainly is
Jupiter.
bringing out some interesting details.
Yeah.
Although I guess it's...
You can see some areas where there seem to be nodules. So what you're seeing are actually gases that are glowing. So as the outer atmosphere of the star gets expelled into space, those gases are energized by the UV radiation from the white dwarf. And the gases absorb that UV radiation and then re-emit it in the visible wavelengths. So yes, the white dwarf at the center does emit visible light as well as UV light. Predominantly, it's the UV light that causes the gases to glow in the visible. For those of you who are familiar with different types of nebulae, the different colors that these gases glow are indicative of the type of atom that is part of the nebula. If you see a lot of red glowing gases, red is almost always hydrogen. Hydrogen alpha is the most intense wavelength that the hydrogen atom will emit in the visible portion of the electromagnetic spectrum. Helium glows, so hydrogen glows red, helium glows kind of a yellowy peach color. Green is often doubly ionized oxygen. And then I'm trying to think of what other colors we have. Blue can be some reflection nebula from the dust that's in the nebula.
Green's pretty common though for nebulas.
Yeah. Yep. Oxygen isn't uncommon in the universe, but it is not nearly as common as hydrogen. Hydrogen makes up 80% of the known atoms in the universe, so. Or the atoms in the universe. Period. It is quite dark out there now.
Yep.
The dome is moving. I would show you the dome view. In fact, I can show you the dome view.
I'll turn the lights on.
But there's not much to see because it's quite dark in here. Woo! Until it's not quite dark in here. But now you can see our fabulous facility. Same equipment that has been in operation for the last 113 years, 112 years. Big yellow telescope is what we use to get up to the eyepiece when
Ladder.
big yellow ladder is what we use to get up to the telescope eyepiece when there is an eyepiece in there. Right now we do have a CMOS camera up there that is giving us the feed into the computer for us to actually look and see what the telescope is pointed at. So for those of you who are interested in actually visiting Mount Wilson, I believe the state of California will be opening up June 15th. That's what the governor is saying. So there will be the possibility for tours up here again, as well as rental of the telescope. So you may not know that you and a group of your friends can actually rent or come up for an observing session on the 60-inch and rent the telescope either for half a night or a full night of observing. And that rental comes obviously with a session director and a telescope operator. So you just get to do the fun part of looking through the eyepiece. There is an eyepiece on the dome, or through the camera if the camera is on instead. But you get to be in the dome, which is so amazingly fabulous. Yeah, you get to spend the night on Mount Wilson, looking through the same telescope that Edwin Hubble looked through.
Oh, this is looking good. Check that out.
Yeah, no. I wish I looked that well at 113.
Stacking.
Oh, nice.
Look at the red giants.
Yeah. I'll show that later.
We'll show that after we
Okay.
get to this one.
They're already going on to the
good.
the target after our next target.
I'm gonna turn off the lights.
All right. So we are going to go back to the attic view. We've got the blue snowball again. Not the blue snowball, the ghost of Jupiter. Someone asked if it was a blue snowball in the chat on YouTube. So
Yes.
I've had that in the back of my brain. It does kind of look bluish in this image, but this is the ghost of Jupiter.
Yeah, it does look quite. Oh, I know why it looks blue. Is because Richard was
As I
adjusting
say,
the colors.
Hubble's not the only one that has its own color palette. we can change colors that we want too to bring out different features.
Yes.
All right, we will start doing this stack.
So obviously the telescope moved. The telescope itself is not pointing at the ghost of Jupiter anymore. The telescope is doing the final slewing over to our next target, which is a very red star called Y Canis Venatici. Venatici? Where's Tom when you need him?
Venatici.
Venatici.
That's because he's a Minigini.
Yes, right.
He's a Meneghini. I am not seeing a red star.
Well, we're maybe not quite
So-
there yet. We're getting there.
They're working on it. So there are many different classifications of stars. just like there are many different classifications of cars, for example. You know, if you're thinking about cars, you've got the sedans, you've got the SUVs and the pickup trucks and various things of that nature. There are different types of stars.
That is out of focus.
And
There we go.
there are stars that are more massive, stars that are less massive. The most, I guess the most significant property of a star that kind of dictates how it will evolve and what we get to see of it is the mass. Metallicity is also important to a lesser degree, but mass, I think, is generally considered to be the most important property that a star has, and it kind of dictates what temperature it is, what color we see, and things of that nature. This is it's out of focus.
Well,
It's definitely dancing around a lot.
Yes.
This is what is known as a carbon star. No, it is not made entirely of carbon. It is made predominantly of hydrogen. But this is an evolved star. It will eventually evolve to the point where it will probably end up as a planetary nebula with a white dwarf at the center. But this is a star that has used up all its core hydrogen, and the next stage for a star, once it uses up all the hydrogen in the core, is for it to puff up and become a red giant. At that stage, you have hydrogen surrounding the helium core, because hydrogen fuses into helium, so the core is helium. Surrounding the helium core, you have hydrogen that starts fusing. The core of helium itself can start fusing, and that helium fuses via the triple alpha process to make carbon. If you add another helium nuclei to a carbon nucleus, you get oxygen. So there's a lot of oxygen and carbon in the core of these evolved stars. Now, if the star has a lot of convection within it, that carbon and oxygen can make it up to the photosphere of the star, to the outer layers of the star. And those outer layers are going to be cooler than the core. The core is like the furnace, it gets cooler as you go out. The carbon and the oxygen interact and produce the molecule carbon monoxide. Now, carbon monoxide tends to like to become, I guess, carbon dioxide. Anyway, the oxygen is used up, and there's a lot of free carbon in the photosphere of the star. And that carbon can interact with other atoms and basically create soot. These are known as sooty stars or carbon stars, and they appear very, very red.
If you were to guess what the surface temperature of the star is, what do you think?
Of a carbon star?
Yeah.
Well, it's red because of the carbon, not necessarily
True,
the temperature.
true. But guess. What's
I know it's on the asymptotic
asymptotic?
branch, and I know where that is on the HR diagram.
2,200 Kelvin.
I would say 5,000, but
Nope.
2,200.
2,000 Kelvin.
That's really cool.
That's very cool.
They're AGB stars?
Yeah.
It's an AGB star, yeah.
Oh, okay, I was trying to decide whether they'd be red giants or not. I think the carbon comes from dredge.
Yeah. Yeah.
Convective dredge.
Yeah.
Convective dredge up. This is all. Did you also tell what the common name for the star is?
Oh, La Superba. Apparently, an Italian astronomer discovered it and thought it was the most beautiful thing ever, and it was just superb.
Oh, actually, we can get Tom. You need to tell us how to pronounce his name. Father Angelo
Okay.
Oh, Secchi.
Secchi. Okay, I would have said Secchi, but Secchi.
Father
Father-
Angelo Secchi.
Yeah.
He's the guy who invented the first spectral classification system that the Harvard computers were from.
Ooh, cool.
Ooh, that was interesting.
He also
Now-
invented the second disk for seeing how quick water is. I've used one towel.
I'm not sure if the YouTube listeners are getting all that information from the grandfather of astronomy over here. But apparently, Dr. Angelo Secchi was the first person to come up with a classifications scheme for stars that the Harvard computers later modified to the OBAFGKM system
Yeah.
we now know and love.
Secchi came up with the idea originally amongst the Harvard computers. The first job to modify that system was given to Antonio Maury, whose uncle, Commodore Maury, was I think the first director of the Naval Observatory and was an old buddy of Secchi's and knew him very well. And so there was a little family get-together there. But then Williamina Fleming worked on it, and eventually Annie Cannon's the one that created the system that we use now.
Yeah.
Secchi or Secchi or however you pronounce it was the first one to do it. And the other thing I had said, which is nothing to do with astronomy, Secchi invented what's called a Secchi disk, which is a white disk that you lower in water. I've used one on Lake Tahoe to get the turbidity of the water, and you lower it until you can't see it anymore, and you measure how much rope you put out, and that tells you how clear the water is in the lake. And that was his invention too. Lake Tahoe's getting worse and worse all the time, but that's not astronomy, and I won't get into that.
But it's interesting, you know, if your brain is just working on how to analyze stuff in the universe, then it's not going to necessarily stick to one
Yeah, that's
discipline. That if your brain is just kind of hardwired for figuring out how to solve problems or
Yeah.
figuring out how to understand material, you're going to do it wherever you are, be it, you know, in an observatory looking at the stars or at Lake Tahoe.
A lot of those old guys did that because back in those days they had to know so much less than we have to know now. They could spread out and study multiple subjects. Now it's so intense that it's really hard to do that. If you're going to be an astrophysicist, you're pretty much stuck studying astrophysics. So there's volumes of stuff this thick you got to know.
You got to learn all the nuances to be able to then go and understand the nuances of the nuances.
It's harder and harder to be a Renaissance person, even though they were mostly men in those days. Not all, but
Yeah. Yep. So
Anyway, the
a little bit of everything.
reason we wanted to look at this object is because the star is thought to be just on the verge of making a planetary nebula. So this is the stage just before what we saw before,
So
astronomically speaking. So
Astronomically
still
speaking.
thousands and thousands of years, but
is anybody asking why the star is bouncing around like
yes. And I think Barbara already answered the question.
I didn't know stars did that.
yes,
They do in
So-
the sky.
someone likes your explanation for the Secchi disk.
Oh boy.
Neat. Yeah, or Secchi disk.
Yay Tahoe.
All right, I think
So it is
this-
bouncing a lot. This is the perfect twinkling star. I mean, this is when you think of twinkling, this is kind of an exaggerated twinkling, and this is all the Earth's atmosphere.
All right, I think next
There we
we're going to
go.
go to the globular cluster.
Like,
So
regrabbing it.
M3, please. I'm gonna bring the lights up.
M3 globular cluster. Oh, we can go back to looking at the dome. Oh, here come the lights.
Forget your night vision.
Night vision. Who needs night vision? So
many variable stars?
M3 is a globular
I just looked
cluster,
at that.
and this is the third in a catalog of 100 and Messier catalog has 110 objects, right? 111.
That are attributed to him, but some of them he actually were already seen, like the Crab Nebula, which already.
Yeah. But is it 110 or 111?
Messier.
Yeah,
I think it's 110.
I thought it was.
But Messier himself only published about 80, and somebody else had all the rest of them.
Oh, well, there you go. More history. So Charles Messier was a
Do we want to bring that up?
I think people are
Okay.
just looking at the dome right now. Charles Messier was a French astronomer working in the 1700s, and he loved looking for comets. So his big interest was comet hunting. But when he looked at the sky, comets, when they're far from the sun, are quite small. Their angular diameter is quite small, and they're very faint and very fuzzy. So he was looking for faint, fuzzy objects, and then hoping that they would grow in size and develop a tail and look really cool like the comets that you will see pictures of. But he kept seeing these fuzzy objects, and he's like, wait, have I looked at that one before? Is it a comet? So he would start cataloging these fuzzy objects that were not comets. As it turns out, these fuzzy objects are really some of the more interesting objects that you can see with the telescope. So as Tim said, he cataloged about 80 objects, and then another 30 or so were added to the Messier catalog. So if you're ever looking at something, okay, let's go over to here. If you're ever looking at something astronomical and it tends to have a M number, like M1 is the Crab Nebula, very famous supernova remnant in the constellation of Taurus. I'm blanking on the Andromeda Galaxy.
M31.
31, yeah. And then M42 is the Orion Nebula, right? So M3 is a globular cluster. And a globular cluster is a collection of quite old stars. In a cluster of stars, they all formed roughly at the same time from the same molecular nebula. But in a cluster, the more massive stars kind of use up their nuclear fuel more quickly. They have much higher temperatures in their core, and the rate of nuclear fusion is much higher. So they burn through their nuclear fuel much more quickly, and they go out more quickly. Now, massive stars go out quite impressively. They go out with a giant supernova explosion. But in a globular cluster, which is a very old collection of stars, then what we see left now is all of the stars minus the very, very bright, massive white-blue stars. So the ones we're seeing tend to be older, and they're more golden and orange and red in color.
Okay, so we're there. We're just focusing
Yep.
and setting
Zooming
things up.
out, getting, the focus is coming in nicely now.
Okay, probably pretty well centered.
Now, the field of view of the 60-inch telescope is really quite narrow. So we are looking toward the center of the globular cluster.
How's the focus?
Can we boost the gain?
I don't know how much better you're going to get just because
Oh, well, there are more stars. They were hiding, a little bit more faint.
Example of the difference between the refractor and the 60
Yeah.
inch.
Wow,
That's pretty good.
that's a field of view.
Yeah.
That's standing.
So we have a whole bunch of astronomers over playing with the the software. You can see the mouse kind of clicking around while these guys have
So we're going to
Have-
try stacking.
fun figuring out the not the filters, but the I'm blanking. What are these?
Oh, so what Richard is doing now is he's adjusting So when you have a CCD camera or a CMOS camera, all that you have in those pixels are numbers. And so large numbers are bright things and small numbers are dim things, but you still have to translate that into how bright they appear on the screen. And so what Richard is doing is he's playing around with
It's ignoring the stacks.
It's ignoring, okay. Well, he's playing around with what we call the levels and essentially assigning what is black. Black, you have to assign a number that should be close to what the background of the sky is. And then you want to assign what white is, and that should be the brightest thing you're interested in. So if you have those levels correct, you see a lot of detail. If you don't have those levels correct, you either have like nothing but white, like kind of getting like where we're there, or you might have nothing but black. So we're just trying to get the optimal view. And probably the other thing you're also seeing at this point, towards the bottom of the screen, is sort of like a haze.
A lighter area.
A lighter area. And this is probably where the electronics of the chip are creating a little bit of heat. And the heat will generate what we call random sort of dark noise. And there's just, the only way you can get rid of that is to cool the chip down as much as you possibly can. And I think we're cooling at, let's see, what are we cooling at? -20. So we've got it down to -20 degrees using a thermoelectric cooler. But on the telescopes, and the seeing is, so-so tonight. I mean, you guys saw when we were looking at the moon, it was kind of shaking around a little bit.
And there's a lot of twinkling with the star.
There's a lot of twinkling with the star. And so when we take these longish exposures, which are probably, what exposure are we using? 3 seconds? 5 seconds?
All right, 4 seconds.
4 seconds. So over the course of that 4 seconds, these stars are dancing around, and so in the end, you get something that looks kind of blurry.
Whereas compared with the refractor, we're almost at 20 seconds, and that's because the 60-inch mirror gets a lot of light.
Yeah.
Yeah.
So yeah, one of the disadvantages of having a large mirror is you're looking through a larger column of air, and so any turbulence, you're just going to be more susceptible to it. It also means we're going to get more background light from Los Angeles or the moon, depending on where we're pointing. So this is the view through the 60-inch, and I guess we might as well show them the view through Richard's refractor, because he's very happy to show
Yes.
what you get when you, how long have you been stacking now?
That's 25, 27, or 18 seconds, so it's a few minutes.
So what's going on here is, instead of taking one long exposure, Richard's taking smaller exposures and adding them up. We call it stacking.
Yep, so there was a question just on the YouTube feed. Can you stack the images in that software?
So
this
one, yes. When we try to do it with the 60-inch,
You need really good clarity for a round star
Yeah.
to stack.
yeah. So probably what's going on is that the software wasn't designed to work with the kind of optics that we're doing with the 60-inch, and it's having trouble identifying those stars. I think they're just a little bit too blobby and too blurry. Whereas here, you have lots of stars to play around with, and so it can use those stars to align the images, and then you can stack, and then you can really beat down the background noise quite effectively.
Yeah. That's
And then
quite
I
a
save
beautiful
them
stack.
for later,
And then you save them for later.
so I can adjust them.
Yeah.
14, 11 or 14.
Now, the other thing to notice about this cluster is there's sort of like a very three-dimensional quality to it, and there are these stars that kind of pop out. They almost seem like they're on the surface over the rest of the blurry background. And these really bright stars are the red giants. So these are stars that are just at the end of their lifetimes. They've exhausted the hydrogen in their cores, and they're now burning helium on the inside. And when that happens, the star has to adjust itself, and it grows. It gets bigger, so that's why we call it a giant. But as it expands, it also cools off, and so they also become redder. And I can kind of see it better in one of our monitors, but I don't know if you can see that they're redder in the YouTube land. Well, yes, you could do that.
I could do that, and everything will get redder. Yes.
Wow, look how red they are. That's amazing.
Yes, we got the color
We
king
control
over here.
the horizontal.
Color
That
correction.
may be copyrighted.
Yes. Shh.
Leave those colors you see in all those NASA pictures,
Yeah, there's a lot of pre-process or post-processing that goes on sometimes with these pictures, but this is pretty much live. And I will say that on a good night, on the 100-inch, looking at something like this, you can definitely tell that those giant stars are red.
Yes.
No problem. Oh, we should probably say what the vital statistics of this object are.
It's 33.9 thousand light years away.
30, okay, so almost 34,000 light years. Okay, so that light's 34,000 years traveling. God, isn't Wikipedia great?
I know. It's multiple monitors. We can
So
bring up everything.
there is a question
Yes?
on the YouTube chat. Mr. Menegini Does Mount Wilson Telescope have any plans for the next total lunar eclipse?
We're formulating that right now. It's going to be very, very low to the horizon, minus 21. And so we would only be able to get 2 hours of it with this telescope.
Okay.
We might use the smaller, we might use the 5
Oh,
inch.
is that the one at like 6 in the morning?
Yeah,
4
all the
o'clock
way
in the
to
morning.
4
4 o'clock.
Yeah, that's not a good time for me.
So, so,
You realize I don't even have to go anywhere. I can remote control this
yes.
from my house.
So it's a definite maybe.
It's a definite maybe.
And you call yourself an astronomer.
I'm not an observational astronomer. I prefer the theory, and I just like making telescopes as well, which all can be done during the day. As someone once said to me, clearly sleeping is your superpower, and I
Yes.
absolutely agree with that.
Well, I did buy a solar telescope.
I've had my nights on various telescopes. I remember back at university, I remember my observing partner and I doing jumping jacks at 1:30 in the morning to both stay awake and stay warm because the snow was coming in and swirling in the dome. So I cut my teeth in the middle of the night.
Yeah, staying up all night sometimes is hard.
It is, especially if you're teaching the next morning at 9.
Oh, yes, it's true. Very true.
All right, so we have, this is a 60-inch view of the globular cluster. Do we have one final target we're heading to?
We're going to try
M82. Okay. M82 is another Messier object.
We're slowly making our way out into the universe. So this will
Yes.
be our very distant.
Try M82. Oh, M82, the
So
double.
the first one was the moon.
Ooh, that's
That was
awful.
fairly close.
Whoa.
And then we had a
We'll try a couple galaxies in different areas.
the Ghost of Jupiter planetary nebula, and Y Canis Vitici, which is a single star, carbon star. Those are fairly close as well. A globular cluster is in the halo of the Milky Way galaxy, so that is farther off.
Okay, here we
And
go.
then now we are heading to M82, which is a galaxy.
Far, far away.
Yeah, it is. It's a fairly famous galaxy. It was in the news. Wasn't it? The
Well,
black
it had
hole?
supernova 2014J went off in it. That was.
Oh, M87 is the one with the black hole.
Oh yeah, M87.
Okay, we're in M82.
Ah,
Nice.
So,
Wait, is that?
again, we're.
that's,
Oh,
no, that's
Oh, the
that's
other one.
needle.
Right, yes. Right.
so I don't know what the telescope
in here, it
is
doesn't fit in there.
showing right now. I can't show you anything in the dome because the lights are not turned on. So as opposed to showing you a black screen, I will show you a very dark screen, but at least there's someone's face there. So how far away are you going to estimate M82 being?
Let me think about that. Okay. Tim says 12 million light years.
That's my guess. I can't.
So about 4 megaparsecs.
So we have the grandfather of knowledge versus Google.
Wikipedia.
Well,
Sky Safari.
Sky Safari is what we're going to use.
So there are various apps for help you kind of figure out what you're pointing to with telescopes or what you're looking at in the sky. Sky Safari is one of the ones that we use up here.
Yeah,
And it's got a
12.
lot of details. And it is
12 million light years or 3.6 megaparsecs.
Knowledge for a reason.
12 million light years. Yeah, grandfather of knowledge came in way faster than Sky Safari. 3.26 megaparsecs.
Yep.
Yep. A parsec is another unit of distance that astronomers commonly use. We have AU, which are the astronomical units, the base of which is the distance from the Earth to the Sun. And then we have light years, the distance that light will travel in 1 year. And then we have parsecs. which is the distance that is how do you subtend? Oh, I just noticed that the
Yeah.
platform was right above us. A parsec is the distance subtended by the angle of 1 arc second.
Well, it's so it's
Parallax angle of 1 arc second.
If you have a star which is 1 parsec away, then as the Earth makes its way around the sun, its position appears to change. It wobbles back and forth, just like if you kind of move your head back and forth. Things seem to, in the foreground, seem to move back and forth.
Do that.
Yeah. And so if a star were 1 parsec away, then as the Earth makes its way around the sun, it would appear to shift back and forth by 1 arc second.
Yes, which is 1/3600th of a degree of arc. And there we go. So I think we've certainly moved the telescope. Right above us is the observing platform, the old observing platform that astronomers of 100 years ago used to use. And I just looked up and saw this giant chunk of metal up there, which is why I did a double take. But I think the telescope is now pointed to the north, a little bit northwest, kind of right above my head. And do we have M82?
We're still moving.
They are still slewing the telescope over to the coordinates at which we will find M82. So for those of you who are new to telescope motion, slewing the telescope is the term that is used when you change directions. So you can reposition the telescope. If you do it quickly, it's just repositioning the telescope. But if you're going slowly, that motion is called slewing, for reasons I've never understood. But apparently we are now there. But we need to, the computer gurus need to adjust the exposure time and the light levels. It's very exciting. So while they're doing that, I did want to mention a little bit about interest that has been shown in this virtual Star Party series that GCC and Carnegie and Mount Wilson have put together for the spring 2021 semester. I think all of us up here on Mount Wilson are really enjoying these evenings and quite pleased to continue them. I have to check with the college to make sure that that is still something the college is interested in participating in. I can't imagine that they would say no. So I rather suspect that these evenings will continue over the summer. As an educator, I am constantly trying to encourage more people to take an interest in astronomy, in science in general, and to make the STEM subjects more accessible and more interesting for a variety of people. So what I am hoping to do is to have some cultural ambassadors join us so that there are people from different cultures who can discuss what those cultures think about the objects in the sky, in particular constellation stories. So many of the constellations that I have become familiar with, having studied astronomy, are the Greco-Roman ones. We have Leo and Virgo and Scorpius and Taurus and things of that nature. To my knowledge, I don't have a lot of Greek or Roman or Italian ancestries. So are those stories really appropriate to my heritage? I don't really know. I have European heritage, but there are so many other cultures that have such a wide variety of amazing stories that they tell about the sky and the star knowledge and the astronomy knowledge of indigenous people in different parts of the world is really fascinating. And I am hoping that we'll get some astronomy ambassadors representing different cultures up here. So that is something I'm working on putting together as a project, if not for the summer, possibly for the fall. I know that my particular community college will have very limited on-campus instruction in the fall, so we will be mostly remote, which means that a Mount Wilson collaboration is definitely something that we are planning in the fall. Over the summer, I rather suspect that we'll be back here regardless, because I think all of us have a lot of fun being up here and sharing with you the interesting sights that we can see. I always teach the first thing Wednesday mornings, so Tuesday nights I'm usually out of here pretty quickly. But over the summer I will not be teaching, so I can stay here till later hours and we can see perhaps more interesting things. But right now, they are working to get a view of M82, which is a galaxy 12 million light years away. So the light that you will be seeing coming through your YouTube feed first left the stars of this galaxy 12 million years ago. What was happening on the Earth 12 million years ago?
Good question. Well, the dinosaurs disappeared 64 million years ago, something like that.
Yeah.
So,
Yeah, so the dinosaurs weren't around
and all
when the light left these.
Australopithecines and stuff like that was like
They hadn't evolved yet.
2 million years ago, so yeah.
Yeah, I don't know what was happening on the Earth 12 million years ago. Couldn't help you there.
Boring 12 million years ago. I mean, you know, Australopithecines, no dinosaurs.
There were a lot of mammals evolving. There's probably lots of very interesting flora and fauna, but I'm not sure what they were.
Uncle of all knowledge over here says
Lemurs.
our ancestors were lemurs then.
Our ancestors 12 million years ago were lemurs. So says the uncle of knowledge.
Focal reducer off.
But we are trying to get an image of M82. Okay, I'm going to go over and have a look at M82 because they're just messing around with a few things. But this is our view of the galaxy M82. All right, so there's someone on the YouTube link. I had mentioned that, you know, if I don't have to teach the next day, I could stay a little later. He's like, yes, let's do a 5-hour session. I'm like, oh, okay, that might be taxing because remember, sleeping is my superpower.
I was gonna say, when we run full night sessions here, they're from 8 o'clock at night to 5 in the morning.
Yeah,
Yeah.
Get too many of those.
No, they're tiring.
they are tiring, and I have in fact slept on the floor of this 60-inch dome. I've curled up over there in a corner because I really do enjoy bringing my astronomy students up here. So we have come as a class, and you know, a 20-minute little nap over in the corner of the dome is very helpful for waking me up a little later. Didn't bring a sleeping bag, but I did have a blanket and a pillow, funnily enough.
Yeah, but
All right, so this blobbishness is a galaxy, and there will be some dust. The darker areas that you can see here is undoubtedly caused by dust. Dust within galaxies and intergalactic dust is not quite like the dust bunnies you find under your bed. These are small molecules, often encased in ice, and what they do is they either absorb or scatter the light. They're about the right size to scatter visible light wavelengths. And you can see here that they're actually obscuring the light of stars that are behind them.
It's an exploding galaxy.
It's a starburst.
It's a starburst galaxy. There's a lot of star formation.
Exploding. You can see it in Spitzer images, in X-ray images especially.
You know, it is really interesting that now, for some reason, our smaller view looks better than over here. It's looking pretty good on YouTube, too.
Yeah, it is looking pretty good.
And how far away is this?
We should be getting a little bit red.
Huh, someone has rain where they are,
12 million?
so they can't be observing with their own scope. I guess they've joined our feed.
We're up above
Do we know if a marine layer has set in?
I
For
don't think
LA?
so. I don't think it has to yet.
No.
We have the technology to check.
We have the technology.
Woo! That's okay. Are you all right? I'm fine. It's dark in here. Someone just walked into a table. So the question is, would M81 be a bit big to see well?
No.
Oh, definitely no marine layer. You want to bring that over?
Yeah, there's no marine layer. There's
So-
there's beautiful glow.
A marine layer in Southern California is when we have
There's a little bit right here.
very low-lying clouds
South
that
Orange
pretty
County.
much blanket LA County, LA City, but it's below our level, so we're at 5,700 feet up here.
Yes.
So the cloud level is below, cloud bank's below 5,700 feet, and we have a lovely dark sky because the clouds keep the light kind of down in the city. Yeah, clearly we don't have a marine layer today because you can see those city lights.
That's not good.
And that's part of the reason why we're seeing a bit of a glow in the background.
Yes. And that is also one of the
This camera doesn't have that.
the reasons
That's why I was
that
wondering, like, what are you talking about?
the big telescopes on Mount Wilson are not used for like cutting edge professional research anymore, because we do have the glow of the big city. So the big research telescopes are now a lot of them being built in Chile,
Yep.
in the Atacama Desert, also atop Mauna Kea in Hawaii.
But we might be able to change that.
Canary Island.
If we
Canary
do
Islands.
observing in the infrared from up here, the light pollution is not important.
Yep.
That's
where
true.
That's where we're headed next.
Yeah, so there's a lot of interesting ideas that have been generated to kind of revive the research projects up here on Mount Wilson. So head over to the Mount Wilson website page if you want to learn more about the programs that are being done up here.
Oh, there we go. Nice.
Follow us on Facebook. Do you guys have a Twitter feed as well?
Yes.
Twitter and Instagram and all those good
Yes.
things?
Yes.
Yep. So Mount Wilson's all over social media. So please come and follow Mount Wilson, and you'll find out all of the cool things that are going on. So I don't think you heard my question. M81 would be too big too, to see with the 60 inch. Yeah?
Yeah,
we
it doesn't
can do it.
Well, Richard's actually got it on his telescope, so we can look at it with that. I think is probably the
We've
better.
we've done M81 before too.
Yeah.
Okay.
Mm.
Yeah.
It's
It's nice.
It's a short haul with the telescope.
Yeah, it's really short. It's really a short drive.
well, if you want to go there, we can always show the refractor image while
Okay.
you're.
All right, we can do,
All
we
right.
can do that. We have the technology.
So we're gonna head over to M81.
So we can bring this over.
Yeah, why don't you bring that over?
Yeah. So they're talking about light pollution in South Carolina. Even Palomar was talking about light pollution. Yeah. It's just we need people to turn their lights off. I think what drives me nuts the most is the people who decide to light up their houses at night or light up the trees. I know what trees look like. I can see them during the day. Lights at night, not so necessary.
All right, so Richard's got a wide enough field of view on his
So beautiful.
refractor that you can see both M81 and M82 at the same time.
And you can see that very exploding region.
Yep.
in
Yep.
M82.
So that's M82. M81 is over on the right-hand side. Both of these are galaxies. Are they interacting?
They were.
Ah.
In fact, the reason that M82 is a starburst galaxy is because it had a close encounter with M81, and that the gravity will compress the gases and sort of give it a jiggle.
Mix things up a bit.
Mix things up a bit,
Yeah.
and that can trigger star formation. And so M82 is currently producing so many stars, and those stars are producing so much energy that it's ripping itself apart.
Yeah. So with that knowledge, we know that M81 is around, hang on, M82. Which one are we going to? M81 is around 12 million light years as well.
Yes,
They've been
they're
interacting.
both around the same neighborhood.
So someone pointed out that you can see the lights of Vegas in Death Valley. I
Oh, yeah.
remember that.
Yeah.
We were in Death Valley, oh goodness,
Many years ago.
that wasn't that long, yeah, about a decade ago maybe.
Well, our children were young enough that they were terrified by the night sky. I remember that very clearly.
It was very, very dark, but off on one side you could see the glow of Vegas.
So are we gonna
Yes.
head back over to the 60?
Are we there yet? Okay, yeah, let's head over, see what we got.
All right.
50 years ago, I could see the Milky Way from Monterey Park from Carver Ranch
Are
Observatory.
you serious?
Yeah.
Wow.
Wow. So Tim was
still
saying
not
50
very
years
long.
ago he could see the Milky Way from Monterey Park.
Yeah. Yeah, it was a naked eye object.
Naked eye Milky Way,
So
yeah.
was M31. It was a naked eye object.
M31, wow, yeah, okay, not anymore.
Nope.
Although there is a dark sky site that we found up
Oh,
Mount
yeah, I
Pinos.
used
I
to-
think a lot of astronomers go up there to do stargazing,
Yeah,
dark
and
sky
if you don't mind
observing.
being around people who aren't always sober, but if you join the Los Angeles Astronomical Society and come to our private land, we're all sober. We're astronomers, but we're all sober.
All right, there's a plug that Tim has for the LAS, which is the Los Angeles Astronomical Society that does have their own dark sky observing site. That if you are a member of the LAS, that you have the opportunity to go and observe up there, where the observers are not all tipsy. So.
I've been up to Pinos when they started cheering constellations.
Wow. Okay. So,
I'll leave it there.
okay, that looks like two headlights of a car
Well, we
from our view.
Ship is coming in.
Absolutely.
we like to be centered, so that's just centering. We should have a
Okay,
good
so you
view,
can see a bunch of headlights here, but
There we go.
there we go. That's better.
The universe is back to normal.
Ah.
But we made a big discovery there, double galaxy.
So, because of our narrow field of view, the galaxy is actually pretty much filling the entire field of view of this camera at the moment.
Yeah, so it's interesting right here is if you, this star right here,
Yep.
and this star right here, if we bring the refractor over, that's that star right there, and that star right there. So the field of view of this 16-inch is very, very narrow,
Yeah.
but it can pull a lot of light from that one
Yep.
area.
And these are going to be foreground stars, stars in our own galaxy.
Yes.
Same line of sight.
Otherwise, they would be huge.
Otherwise, they'd
Yeah.
be supernovas.
Yeah, I was about to say, whoa.
Unbelievably bright.
Yeah.
But well, I mean, 10 million stars in that white dot? Big
Oh
dot in
yeah,
the center,
sure.
Easily?
Oh yeah. That's.
There's probably 100 billion stars.
I know, in the whole thing.
Yeah.
But just in the, I mean, that's just the core.
Well, there could be close to 100 billion just in the core. Nobody knows the number. You ask people how many stars are in the Milky Way, you get 100 billion, 200 billion, 300 billion, 400 billion, who knows?
No, it's good. 100 billion between friends, yeah.
In the low hundreds of billions.
If astronomers only care about getting the right number of zeros, that's if we can do that, then we're in
pretty
pretty
close.
pretty good
Precision
shape.
astronomy, right?
Yeah.
That's right.
Thank goodness for scientific notation.
Yeah, just as long as we got the E component right.
All right. Oh hey, the ARC Center of Excellence for Dark Matter's back.
Yes. Yeah. Didn't realize that M82 had such high surface brightness. It is pretty bright.
It is, yeah. Actually, M82 is really great for telescope viewing. It sort of pops out a little bit more than M81.
Down the stairs.
Yeah.
Hey, Robert. Actually, that's pretty much it for us.
Yeah,
10 o'clock.
it is. Oh,
Yeah.
yes, it is. Soon to be 10 o'clock. A few
6.8
minutes.
and 8.4.
So I think that's going to wrap up our observing for this evening
With
with
both.
the last view
Put that
of
there. I'll bring the lights up.
yeah, the refractor view of M81 and M82. Excuse me.
Hey, the lights are on in the observatory.
The lights are on in the observatory. Yeah, if we go back to the dome view. Oh, yeah. So you can kind of see the platform right above my head. That's where astronomers used to observe from when the telescope was pointed over, if they had to look through, I guess, the prime focus or use the prime focus. But
Newtonian.
Newtonian focus. So yeah, I guess we will post on our various social media feeds and on the planetarium's website at the Glendale College website what will be happening over the summer and next fall. But with luck, we will be back. I rather suspect there may be additional people who drop in now that the telescope is back up and running. There's a lot of people for whom observing is a real passion. And I have heard from a number of people that they're quite jealous that I get to come up here every 2 weeks and observe and enjoy the universe with such an amazing group of astronomers. So I think this is it for this evening, at least. So I do want to say thank you, everyone, for coming and joining us tonight and joining us this semester, since really February I think we started. I hope you've enjoyed these live streams and the virtual star parties and all the mistakes and all of the learning that we have done. As you can undoubtedly tell, we are not professional YouTubers, we're not professional videographers, and yeah, we have our glitches, and we're still learning about these CMOS cameras that we've acquired recently. So, you know, live and learn and practice and get better at things, and hopefully we will be back and you will be able to join us in a matter of weeks. But for tonight, and I think from everyone here, we wish you good evening and clear skies and amazing observing.
Night.
Good night.
Night.
Good night.